Okay, got a video going up now today. I was having some OBS issues last time, but you should be able to see my face while I'm doing this. Um, this week, I wanted to give a bit of an update on what I accomplished. Um, not so this week for me was more about um, kind of refining my process, cleaning up some of my workflow, and making a couple additions to my project build process. So that's kind of where I'm going to be reviewing for this week, and then preparation for really getting down to generating code for a calculator application using my process as best as I can. So let's start with the some of the things that actually, let me start with the Basic09 reference. So this is my updated code. I've got some stuff to check in my GitHub project, but um, just to kind of review where things got tweaked and fixed since my last time. So when I posted my generated results and my video on the Discord, the Coco Nation Discord, got some really good feedback from some of the other members and gotten some good suggestions on how to clean up my code. So I've switched over to using the exclamation mark notation, which when you load that into the Basic09 uh, uh, application on Nitro OS 9, it'll convert that into an REM statement. But so my workflow for this code generation is all done outside of the Coco. I'm using Visual Studio Code on an Ubuntu installation, again on my Windows machine. And then I use MAME to fire up my code changes and test it out, kind of thing. But like I said, I'm doing all of my editing in Visual Studio Code and checking that code base into a GitHub project, which again, I'll have the link will be in the description of this video on YouTube as well. So I've gone and cleaned up and sort of incorporated many of their suggestions to sort of making this code a little more sort of standard to the way most people are using Basic09 to develop code for the Coco 3 and Nitro OS 9 in modern day. I also cleaned up some of the inefficiencies. I think that one of the big ones was I was using GoTo on my choice menu here, and I switched it to a Go sub. I haven't touched Basic of any variation in quite a long time, and so I completely forgot about Go sub. But Go sub is as compared to GoTo, allows you to go off and call code, and then instead of having to go to from that code, you can just hit return. It'll go back to exactly where we were before. So essentially, my main loop now goes on a repeat, and it looks for a choice. Oh, the other thing I added was I got get working, so it just gets a key press, and now it'll just loop until you choose a key between the options, so 1 to 4. So I've got my logic here to sort of make sure the value's between that, and if it isn't, it'll just keep repeating until you press a correct key value. And then I use that choice to split off to the different options. So now I create my file, read my file, list directory, or quit. And then there's a little error handling block afterwards, and then after that, right, yeah, so this is the end. This is where it drops out of the loop, is that once it hits done, once you hit 4, it'll come here, hit print, it's terminated, and then end the program. Now, one of the things that I was working on, again, I'm trying to balance between writing proper Basic09 code, but also trying to improve the way that I'm building my code so that I don't introduce redundancies. So there's definitely flaws with, Basic09, and along with any Basic from this era, is, like I said, it's very simple. It doesn't have some of the real, what are really kind of standard behaviors in programming languages that sort of came out in the years and decades afterwards. And one of the real downsides is that there's no real concept of global scope inside of Basic. Everything you write, whether it's a comment or an expression, has to exist between a procedure declaration and the end of that procedure. So you can't have like a global type declaration, which would allow you to have like a struct that you could share across procedures. So if you're writing this in pure Basic 09, you effectively have to redeclare that type in any procedure that's going to reference it, even if it's being passed in as a parameter from another procedure. And same thing, you can't declare like a global constants and that sort of thing. So one of the the main LLM workflow that I worked on this week was trying to find a solution that would allow me to not have to type duplicate code, but still get properly declared Basic 09 at the build process before I move that onto a floppy and then have that floppy loaded up in my Coco emulator. And while I'm here, you can see this is my Coco 3, and this is my full setup of my Coco 3. You can see the expansion pack and the disk drive and all that sort of stuff. So I do actually have real hardware, and I have the Coco SD C, is that what it's called? The little cartridge expansion that you can put an SD card into. So I can run my code on a Coco 3 actual real hardware, and I will do that at some point. Although mine's only got 512K, whereas the emulator I'm using has 2 meg, which is the maximum memory you can do now. But I actually have a period appropriate, like an actual 512 that was upgraded when this machine was brand new. So I will get this up and running on real hardware at some point, but like I said, for my development process, I want it all on my computer, and I want to be able to write my code, generate it out to something that I can load on an emulator, and then test it out. So in the interest of trying to streamline that process, and like I said, to make sure that I'm reducing the amount of duplicate code that I need to write, but still get proper Basic 09 syntax on the output of that. The big thing that I did this time, and I'll get my ChatGPT chat up on this just to kind of cover what we were doing. I'm just going to clean up this here so we can see just the conversation. So I started off with this was earlier, it was about a week or so ago, I think, when I did this first little bit of exercise. I'm developing Basic 09 code, and I'm trying to come up with some strategies to manage some inefficiencies in the language. So, for instance, type is a similar concept to struct, like in C. So it's essentially allowing you to sort of gather common attributes into a single type, which you can then use and pass around potentially. But they can only be declared within procedure scope and can't be passed between procedures. So again, that's one of them. Error codes and other constants, again, can only be declared within procedure, and again, in fact, nothing can be declared at global scope except for procedure definitions. So these types of issues mean a lot of duplication in the code base, where multiple procedures need to reference the same type or codes. Can you suggest some options to help reduce these issues? Now, again, all keeping in mind, especially with ChatGPT, it knows a lot about Basic, but it knows a lot about other basics and knows hardly anything about, in fact, I don't think it knows anything about Basic 09. So again, one of the things that you end up running into is that it'll tell you it's creating Basic 09, but it actually gives you like VB or other strains of Basic in its language syntax, because it's just not proper language. So, but this was me brainstorming and just trying to get, okay, well, what are the sort of things that I could do? And it gave me some different options, but this is the part that I really, well, no, not that exactly, but effectively what I came up with was an idea of a preprocessor. So I gave it my build script, and oh yeah. This is, I'm not going to walk through this whole conversation just because I was kind of figuring things out, but I'll give you the high level gist of it. Essentially, I passed it in my build script file and I said, here's what I was basically trying to do. I want a non-Basic09 syntax to mark where I want to inject types and or constants. I also want to be able to replace those sort of a meta syntax with the actual types and declarations, and I'm going to basically create a types file and a constants file in my project that my build script will go and look up. So if I reference a specific type, it'll, when I do my build to generate my floppy, it'll actually, before that, it'll do sort of a look and find for my little meta tags and replace them with the actual definition inside of my types file. So I only have to declare my type once, but I can inject it multiple times. Any place where, any procedure where I need it, I can essentially say, here's where I'm going to use that type, and it'll do that in the build process for me. Same thing with constants as well. Again, when I'm looking at a calculator app, and we'll go into this a little more detail in a minute, but I also want to have, like, error codes is a good thing. I want to have a sort of a constant error code set that I don't want to have to go and redefine in a bunch of different procedures. If I'm referencing error codes for different types of error handling, I want to have a constant list and then only have to update that value once, and then have it generate across the entire file. So, and again, one of the things that I'm trying to do in using LLMs is I try to write as little code as possible. Not write any code, but especially the first pass. I'm trying to get it so that the LLM will do my first pass and get me, 80 to 90% of the way there, and then I can go in and do a code review, make any tweaks or changes, and then maybe refine my prompting process to prevent obvious errors that it does each iteration. So, effectively, what I ended up going through, and this is a big long conversation, but what I ended up was sort of iterating on this big long conversation was I'm looking for my build script addition, and is essentially an awk call to go and marry those type and constants files in with my source code for all source in my project. So that's what this conversation is. And again, I'm going to go quickly over, it's not all that important, but I ended up getting, let me get to the very bottom here. I think I ran out of prompts. This conversation got so long that I ran out of, I couldn't keep using this. So, but I did get it to generate a new prompt to kind of start. I still wasn't quite getting what I wanted, and it was doing some of the common things that LLMs do, like, every time I gave it the source code, it would rename parameters or variables, or, it wasn't staying consistent, wasn't following certain rules. So I wanted to extract out towards the end of the conversation, I asked it for, let me see. This is me troubleshooting. But effectively, I asked it in the conversations to give me a prompt to start a new conversation so I could sort of tear off a new sheet, as it were, metaphorically, and start from scratch with all of what I wanted and give it my build script. So now if I open this up, this is the one where I actually got the version that worked. So this one, I gave it my build.sh file, which, if I go back to VS Code, is this project root build script here. So my GitHub project is meant to be a project's top, like sort of a meta level of a folder with a build script that does a couple of things. It has a new project script, which, this one here, which can set up a brand new projects folder within a new project folder within as a subfolder of my projects, which you can see here. That's what NitroOS 9 examples and I've checked much of the source that's within my NitroOS examples folder into the same project, because I'm sort of giving it as I'm keeping it as my example template project. But if I was going to do sort of a one-off new project, I'd have a separate GitHub inside of that sub project folder. But again, this is sort of my my build process, generic retro software development tooling. So I'm not, my long-term goal is to use this for all sorts of different types of retro projects. So not just necessarily the Coco. I would like to do MC10 code generation, as well as I've got quite a few retro systems. So some of the other 8-bit systems, or even maybe 16-bit systems. I also would like to target other code bases instead of just Basic. I might do C, or I might do assembly. Again, depending on the platform and the languages available. But right now my focus, until I kind of get a successful workflow for the Coco 3, Basic09, NitroOS 9 development process, that's my focus right now, and then in the future I might add to it. But the other one is the build.sh. So this build.sh is again kind of a universal build script that sub-projects, like my projects that are inside, like the NitroOS 9 examples one here, will call. So they get inside of them a very simple, let me close all these other folders just to simplify this up here. So inside of my NitroOS 9 examples project, for example, I have a build script. This is auto-generated. It's just essentially as when the new project script is run, it prompts me for a project name, a target type, and an image name, and it'll then generate this script file for me inside of the project folder. And then in order to build my project, all I have to do is at the NitroOS examples command line, which opening over here in my command, all I have to do is call .build.sh inside of my NitroOS examples folder, and it will call the parent build.sh, which is this line here, with the project name, target type, and image name. And then this is the one that does all the real work. So before I made my modifications to this, what this script did was it would go into the project as passed in by the parameter. It would go into that project folder and look for source basic, and then it would copy every file in here into a using toolshed. So toolshed is a set of libraries, or it's a library that contains a set of tools that can create and manage disk images for, I think it does all the Tandy, or at least the Coco and the MC10. It might handle other things, but I believe it's specifically for the color computer, but I also think it handles the MC10 cassette format, although that might just be the same format as the Coco. I'm not sure. Anyway, like I said, I haven't gotten into the MC10 side of things yet. My focus right now is just the Coco side. But what it was doing was grab all those files and throw them into, here. So based on the target type, and the only one I'm working on right now is floppy. I will work on cassette and hard drive, but those aren't currently being, I haven't even tested them yet, although it should allow you to copy the contents over, and it'll overwrite any files that if it's got the same file name, it'll just replace what's there. So I can run this multiple times and update that same disk. And so it's writing it to the same, so in this case, it's writing it to the image name called NitroOS 9 examples. And then if I go to, let me open up another here and go to my, so this is my MAME installation. If I do a list here, you can see there's a cocodev.sh file here. And in here is where it loads up explorer.exe. There we go. So the current folder, that opens it up. Okay, so here's my cocodev.sh. Let me open with Visual Studio Code. Yeah, that's fine. So all this is doing is calling MAME and setting up, so it's doing a 2 megabyte RAM, setting my resolution. I changed my resolution to something that'll actually show up. I've got like a 4K screen here, so I just want something that'll fill up most of the screen. My floppy 1 is the NitroOS 9 floppy. Floppy 2 is my NitroOS 9 my NitroOS 9 examples disk. So this is the disk that gets generated. This gets loaded by MAME into memory, and then I've also got the hard drive and also a blank hard drive here. So if I wanted to, I could build to this as well. But anyway, right now I'm just targeting a floppy for my source code. So everything gets dumped into that NitroOS 9 examples disk, and then it gets loaded up inside of my MAME installation as one of the floppies inserted, and then I can load it up using Basic09. So back to this build script. So the big thing that I added in now is this big block of logic that starts with the source path. So this is where my basic code is. This is a build path. So this is now where my source is coming from that gets copied onto the floppy. And this is going to be all auto-generated code. So just to kind of review it here, and again, I'll check all this in. You can see right now I haven't got a check-in for it yet, but I will do that before I upload this video. Inside of the source path, there's a types.b09 and a constants.b09 file that store. Let me show you what those look like. So this is my types.b09. So here I've got all of my type declarations, one-lined here with their name, and then what their definitions are. Then my constants is here. So here's where I've got a constant for device ID and some error coding. This will be for the calculator application. And then if you go to my Basic09 reference, the other big change that I made, and I think I don't get to them until down here a little bit, is this. So now you can see, so a couple of other things that I modified as I was getting feedback from the NitroOS 9 community and Basic09 community was I had been using the shell because that's what the code generation did, to go and read the listing of the directory and then writing it out to the console or the terminal. And I was shared this much more sort of Basic09 way of doing the same thing. So here we're actually opening up the directory based on the directory name passed in as a read and as a directory. And then for when you use the open command on a directory in this way, you can, every line that it reads is a folder. And we are, I think, so the code that I've got right now, it's similar to any sort of, like Unix in particular. If you do an ls on a Unix, let me show you that. Actually, it's easier to show the tell. ls-lsa, I think. Yeah. So you can see the first two folders are dot and dot dot. So current folder, parent folder. I'm not showing those in my display, so that's what this logic is doing. It's just filtering out the dot and the dot dot, which are the first two lines, and then it's taking them and printing out the directory names. But there was a type that was declared in here, which was dir entry. So this is got a file name and then LSN, at least, which is, I guess, is the extension, I think, which is a byte. Well, maybe I'll have to look and see what that is. I haven't actually fully reviewed that code. It just kind of worked. But anyway, now if I wanted to use that type in multiple procedures, all I do is use this meta language of @ type, and my build script will look for @ type, take the name at the end of it, go into the types file, and pull out that type and do a replacement. And then in the build folder here, you can see the same, here. So now it replaces that type with this type here. So now this is the actual replacement. And the same thing goes for, let me go back to the source. I did the same thing for constants. So I did @const and then the name of the constant. So in this case, this was another little helper. I haven't incorporated this into my tool quite yet, but I added in here just sort of to flush out my basic reference with a couple of the examples that I want to be able to hand to an LLM. And this is the only constant that I kind of have. This was hard coded to the terminal, essentially. So this is, when you call this procedure, it will, whatever device ID you pass, it'll go to that, it'll look up that device, it passes it in as register A. This is actually an assembly call, essentially, or a machine language call, where it's calling the systems. There's a specific system code, which is this one. And I'm not going to get too deep into the assembly on this video, but essentially for a window, this call will it gets you some information about it, and what we're pulling out is the name of the device. And so in this case, originally it was hard-coded just as a 1. I've now pulled that 1 out into a constant, so I've got device ID here set to 1. So if I wanted to change the target device that I'm that function looks up, I could just change that out to a different value, and it would actually go look up that device and then give me the name. So back to my code here. So basically, well, this has been the big refinement for me, is about getting types and constants in particular, because like I said, those are things that will be the most likely to need reuse between procedures. And so to prevent myself from making, the common mistake of things that are supposed to be duplicate, but because I have to write it twice, you can easily get discrepancies and then introduce unintended bugs or errors. I just declare it once within my types file or within my constants file, and then if I want to change it, I just change it here and it'll get updated everywhere as part of the build process. So that's kind of the big refinement that I've done in this. So now the other thing that I've set up is I'm working through refining my specification workflow, and sort of my workflow to start generating a calculator. So again, I think I touched on this last time, that my basic reference is meant to be just kind of a simple little template that sort of shows all the different variations in what Basic09 can do. And now I want to take that modified reference document and pass that into, and develop the workflow to be able to pass that plus the specifics of what it is I want the LLM to generate to an LLM at once, and then have it spit out the code that I want, and then I can take that code, put it into my code base, and do some testing with it. So again, just to highlight where I'm going next with the video, with this series, is I'm working on a full-blown scientific calculator, because I think this is going to kind of cover everything, including being able to do graphing and do file entry, file read writes, to do screen manipulation, and to do mathematical things like trigonometric functions or exponents, logs, that sort of stuff. I want to have and even programmable, like binary and hexadecimal operations, that sort of stuff. So this is going to be kind of my kitchen sink application that will really demonstrate all of the functionality that's available to you as a developer for Basic09 within one application, and that will be sort of my super template for code generation. And I'm anticipating, at least for the near term, I won't be able to, it's going to be long enough that I probably won't be able to use the whole source for every type of code generation. I'm probably going to have to take snippets or figure out, again, this because of the limitations of currently a large language model token, or like a size of a conversation is very limited, especially with ChatGPT or Claude, where you're limited to I think a few thousand words, essentially, roughly. Google's Gemini is about 4 times the context window size for a conversation, so that it might be a little more possible to use this calculator template in that large language model. But like I said, over time, these context windows are just going to get bigger. Much in the same way that early computers, like the 8-bit computers, were limited in, 48K or 64K was a pretty hard limit for the first decade or so of early computing. We're kind of in that early era of large language models, which 5-10 years from now won't be a consideration. You'll be able to handle it, hand it the entire, a really robust and deep template source code that has everything that you need, and then that's kind of where I think you'll approach that potential 100%. I give you what I want, I tell you what I want, and I give you the sample code to show you how to write it, and then it'll give me exactly what I want, and I'll have to do very little modifications. But like I said, this is the experimental days and early days, and I'm just kind of having fun figuring out just how far can I push within the limitations of LLMs to generate code that works in these very limited hardware software or hardware tools from decades before. So that's where I think these ones, data block. Oh no, here we go. I've got this open. This is the specification doc that I had generated last week, based off of I gave it the template, my basic reference template at the time, plus a description of what I wanted, which was the scientific calculator, like a full-blown calculator with a whole multimodal calculator, basic scientific statistical programming, and said, give me a big specification doc. It's not, the specification doc isn't perfect. There's lots of modifications to do to it. And it's also got some, like for instance here you can see, this certainly reads better, but this is not proper Basic09 syntax. You have to have all the type stuff on the same line. At least that's my understanding anyway. And also you can do some cleanup, like here, calc state here, because these three attributes are all real. You can simplify the declaration by putting all the parameter names, all the attribute names, comma separated, and then just say they're all of type real, and these ones are all of type byte, for instance. So so I've done that manual conversion, but again, my long-term plan is to have these examples to show the LLM, this is what I'm looking for, this is how I want you to generate this code, and then have it copy what I'm doing for new tasks. Same thing with constants. So constants here, I've got a whole, other than this device ID, all of these are sort of in preparation for my work in this coming week, which is to start building that calculator app using LLMs to do the majority of the code generation, and then I'll go and refine both what it generates as well as if I can identify new consistent flaws that it does, I'll make modifications to my reference code to help clarify that, or even in my instructions. Speaking of instructions, I should also point out, while I'm in this folder, I have a prompts folder here that's also in my source for this, where I've been storing certain system prompts that I've been using when generating code. So this is the system prompt that I had been using. I should go back and review this and see if there's any revisions to it, but this is the system prompt that I used to do the generation for, I think it was for this basic reference. If it wasn't, it may have been refined since then to use it to generate some of the sample calculator stuff. This is my first pass. What I did using that specifications doc and set it to do week 1. I'm not going to go into depth on this because I'm going to probably replace this whole file or get it to regenerate it again now that I've kind of refined my workflow, but that's what this prompt was for. I've also added in, and again I'll check this in, but this is the system prompt that I used where I gave it my shell script, this project level build script, and gave it the instructions to make modifications so that it did the types and constants string replacements. And again, the first few times I got it to do this awk code that it gave me, or the script code that it gave me, didn't work or had flaws or didn't quite work. And even this isn't quite perfect, like particularly This is not working right now, this where I have an output log, and I don't think it did some of the other... here, actually, why don't I review this? I think I've got time to do this. So I tell it I'm going to attach the build.sh folder, so that's my root project. So that's this file here. It's called from a project subfolder's build.sh file with 3 command line parameters: project, target, type, and image name. So these are the actual variables in this parent build script that get populated with those arguments. And then I told it, modify the script to insert a pre-processing step that replaces @type and @const references in the source basic and any B09 source file, excluding the types.bo9 and constants.bo9 file with definitions from those 2 files. Follow these requirements exactly. And so I said, maintain my script's variable naming conventions, because, like I said, one of the things that it does is it likes to rename variables and do different naming conventions sometimes even. It also tried to add case insensitivity, and I don't want case insensitivity. I want these to be specifically name matching, like case matching string replacements for both string matching and file search. So again, I want types.bo9 to be lowercase, constants.bo9 to be lowercase, so that's what that line's for. Perform the type constant replacement step before the floppy creation logic, and then replace source path in my build script. So again, in my build script, actually, let me move that over so we can look at this at the same time. I'll move this over to this tab. And then back. No, don't. Over here. There we go. So down here it replaces source path. So in the original source path was, like I said, was coming from source.basic. So now I want my floppy codes, instead of pulling from there, I want it pulling from the build path. So for the purposes of doing the string replacement, it's still using that source path, but then once it's done all of its string replacement, it just overwrites that variable and uses that. Otherwise, probably could just have used reference build path down here, but that's what I did. Maybe I'll clean that up later. But yeah, so then just overwrites the source path, and then source path is what gets pushed onto that build path is what gets pushed onto the floppy code here. And then I just told it I'm going to copy and paste it, so I don't want it to give me anything but the code that it generates, the rest of the source code. And this again is kind of one of those tips as far as workflows go, is if you want it to not touch certain blocks of your code, but you still want that code handed to it for reference, this is what this instruction is supposed to help solve, is to say, I only want the code that you're going to write. I'll manually do the code and copy and replace. And again, like I said, if you're using large language models within a tool that's built into your IDE, like Copilot, you could just do that inline and maybe work that way. But again, I'm trying to do this in a simple, an accessible way. I don't want to have to, like Copilot, I believe you still have to pay for. So I wanted to do this in a way that if you wanted to reproduce what I'm doing, it's not going to cost you anything. You can do this and again, you don't even have to be tied to a specific LLM. Most of them will work with this to some degree, but other than the context window issue, you should get fairly similar results regardless of what language model you use. For missing type or constant, I should remove, maybe it's just an indentation thing. Oh, that is an indentation thing. Here, I'll fix that now. Yeah, okay. So if the type or constant reference, so this means in my source code, let me bring that up to, bring this over here. So if I have a register or a device ID in my source file that's not found in either the types file for type declarations or constants file for const definitions, it's going to do 2 things. It's going to add an REM line to the generated Basic09 file that says couldn't find this register, this type or this constant. And it's also going to, it should log it out to the build log. So in the console, you should see it as well. Just to help point out, oh, you referenced this, but it's not there. And also, if it can't find the types or constants B09 files, open an error and exit. This is just assuming at UTF-8 encoding, multi-line type definitions are not supported. So again, when it tries to do types, it seems to, again, like to do multiple line declarations, and that's not legal as far as Basic09 is concerned. Definitions can appear in multiple locations within a source file, so that's just telling it I could actually reference register 3 times inside the same source file, and I want them all to be replaced with the same thing. Preserve the original indentation, so if this was indented like that, it should maintain that indentation just for code styling, and for type or constant references maybe inside nested if blocks or things like that. Or anyway, that's a superb white space. What's next? Where was I? At the end of the build, output a log. Yeah, so this is the one that the code that it gave me. This it does spit out these values, but it just says 0, 0, 0. So the logic to count the number of files processed, count the number of replacements made, and count the number of missing definitions, that logic's not working right now. I'm going to have to refine that maybe, but it's not important because it's doing the important stuff. It's the fact that it actually works. Handle possible CRLF, so /r/n line endings in Basic09, so just to handle the Windows Unix line feed, carriage return line feed discrepancies. If it's an issue, handle a verbose mode. I don't know if it did that actually either. I haven't tested this. Again, there's a couple of little nice to haves that I threw in here that I haven't yet tested. So a verbose would be something that I'd have at different log levels essentially. Ensure that it works in a standard bash environment without requiring special shells. So again, we want the syntax and the language and the tools that it uses to work in a standard bash. Keep type and const lookups exact, so no partial matches, no regex looseness. So this is, again, I want it to match the string exactly. And this was because I think some of the code that it was generating before was being a little loosey-goosey. I just wanted to be explicit. Output replacement lines exactly as in the source definition file. So again, I want it to be very precise and follow when I'm giving it exactly. Don't go off script. Replacement should never alter white space in unaffected lines. So that's where it's... Oh, I've got that twice. I can clean that up, I think. That was defined twice. And then I give it an example of what the type and const replacement should be. So this is what it should be expecting in like basic reference B09, and then this, so type, my type, this is what it'll find in types B09. Same thing with const, we'll replace it with dim, my const, and then it'll grab it from the const's B09 file. Oh, that's in there 3 times. Okay, I got to clean that up. We don't need 3. This is triplication of the same indentation rule. I can clean that up. And then this is just supposed to catch errors early and terminate. So it was just a recommendation that the model said it's in there. I haven't gotten too deep into robustness testing, so as long as there are no errors, this code works perfectly. If there's something unexpected, I haven't really tried to do all the edge case testing to see if this thing handles errors gracefully yet, but this was sort of a first stab at trying to get it to do error handling within the script code that it generates. Okay. And then I've added a couple other ones in here. You're welcome to... these are going to be checked in. Well, I don't think this one was checked in, but I'll do that as well. This was one where I think I showed this last time. Was in... Did I do a... Oh, I did here, HTML. That was this color picker. This color picker HTML, which I also posted on the Coco Discord, another channel, I think. Around the color, what the 6-bit value is for both RGB and composite, and what they look like roughly using a web page. So sort of as this is if you look at this HTML page in a browser, it'll let you kind of tool with it. But this was all generated by the large language model, and this is the prompt that I used to do that. So again, I'll commit this and make sure it's up on my Discord before I publish this video if you are curious about to see how to get it to generate HTML. HTML on, as opposed to Basic09, which again, like I said, is a obscure and obsolete language that there isn't a lot of information online, and certainly the information that is there has not been passed through trained, these models haven't been trained on. So but HTML on the other hand is universal to the web and central to it, and both HTML, CSS and JavaScript, it does a pretty good job as long as you're clear in exactly what your HTML needs are. It should generate you quite good HTML. And so if you're curious about how to do that, again, I'll make sure this prompt is checked in and posted onto the GitHub project. And you can test it out yourself. Grab this prompt and generate an HTML or make modifications to it. But yeah, that's what this has done. So I've taken all the stuff from the training documentation that I could find that was specific to what the actual values are, and then I got to write the HTML source code that has JavaScript and CSS and HTML that will actually let you see what that, if you choose a specific bit value or you choose a specific color, what does that actual 6-bit value look like? Okay, I think that's all I wanted to talk about this week. Like I said, next week will be a video on now that I've kind of refined my workflow and I've made some changes, I'm going to start trying to get it to generate a start screen for a calculator and maybe some of the initial functionality. And we'll see how far I get. If I get really far, I'll have a fully functional basic calculator to show you. But in either case, I'll see you next week. Thanks for watching.